mission.
Planning a vacation to Uranus? Time to study up on what you're about to get into. 63 times larger than the Earth. Here, you'd be lucky to celebrate a single birthday. The planet takes 84 years to make its way around the Sun. Uranus and sister Neptune are known as the ice giants because of their frigid outer atmospheres, supercooled to minus 355 degrees Fahrenheit. But the biggest, most obvious feature about Uranus is its crazy tilt. However, it wasn't always this way.
The traditional explanation was that while Uranus was forming, it may have been hit by a larger chunk of accreting material than normal and actually knocked it over on its side. The problem is when you do the maths on this, it doesn't work. It's very, very difficult to get a large enough body traveling fast enough to be very credible at knocking Uranus over on its side.
Rather than being pounded, it's now thought that Uranus may have been swept off its feet by the gravitational tugs of its giant neighbors.
Uranus's tilt actually results from rather complicated interactions with Saturn, Neptune, and Jupiter even. All of these planets do have gravitational effects on one another, and the effects are more subtle than we used to think, and it's dynamics, not a big smack in the face from a large impacting planetesimal.
Imagine if Earth were like this, tilted on its side. Equatorial jungles would turn to ice. In summer, the Arctic Circle would evaporate and become a steaming tropical paradise. What would be north? What would be south?
You can get into very long, heated discussions at a bar with astronomers about what the North Pole of Uranus is. So don't go there.
If tilting the Earth causes weather chaos, what is it like on Uranus? Do the clouds spin on the same axis as its tilt, or differently? Scientists have many questions about the first ice giant. When Voyager journeys to the outer solar system in the 1970s, it beams back astounding images of Jupiter, Saturn, and many of their moons.
The wonderful thing about the Voyager mission, we saw so many things for the first time, and they were all so different, so diverse and distinctive.
Being there when the images are coming in makes you feel like you're on the bridge of the Starship Enterprise, because you really feel like you're there. Those are just your sensor screens, and you're getting reports back from these alien worlds that you're taking a look at.
Who could ever have enough pictures of Saturn's rings?
So what do Voyager's cameras reveal of Uranus, the lopsided planet?
Well, Uranus was a real enigma for us. So we didn't know what to expect.
In 1986, after a decade of traveling through space, there are great expectations for the seventh planet from the Sun.
From the Earth, it looked kind of bland, and quite frankly, from Voyager, it looked kind of bland too.
The images of Uranus were a little bit disappointing.
It's a very bland planet with very few clouds.
Not much going on at Uranus.
These are the first images of Uranus, taken from Voyager 2. The planet appears as still as a pond, with no cloud detail at all, and it's silent.
We did not hear a whisper from Uranus before the Uranus encounter.
Unlike Jupiter, whose magnetic field roars across the radio waves. At first, Uranus doesn't make a peep.
Part of that was because the radio source was on the other side of the planet where the strong magnetic fields are, and they were beamed away from the spacecraft.
Voyager discovers that Uranus's magnetic field is wildly off-kilter.
You have one hemisphere with very strong magnetic fields, stronger than the Earth's magnetic field. You have another hemisphere, the one pointed towards the sun, with very weak magnetic fields.
Planetary magnetic fields require the movement of charged particles. On Earth, this occurs in our molten iron core. So what's driving Uranus's magnetic field? There's more going on here than meets the eye. That's the beauty of traveling the solar system. It's full of surprises.